Welcome everyone. It's great to see so many people today. It's my great pleasure to introduce our guest speaker today, Professor Willy Susilo, who will talk about blockchain and its applications probably as well. Everybody should know, really, of course, here, but for the sake of the presentation and introduction, just to remind you that Willy received his PhD degree in computer science from the University of Wollongong, best university in the country. He's a senior professor and the head of the School of Computing and Information Technology and the director of the Institute for Cybersecurity and Cryptology, IC2. He was previously awarded the prestigious ARC Future Fellow by the Austrian Research Council and the Researcher of the Year in 2016 by the University of Wollongong. His main research interests include cybersecurity, cryptography, and information security. His work has been cited more than 9,000 times, and I'm really jealous, really. He's the editor-in-chief of the Information Journal. He has served as a program committee member in dozens of international conferences. He's currently serving as an associate editor in several international journals, including Elsevier Computer Standards and Interface and International Journal of Information Security. Previously, he has served in many top-tier journals, such as IEEE Transactions in Information Forensics and Security. He has published more than 400 research papers in the area of cybersecurity and cryptology. So we've got the man who knows what he's going to talk about, which is great. Please join me to welcome Willy for his talk.
Thanks, Pascal, for the nice introductions. I think it's really a great pleasure to come here and to talk about the issue. One of the hot topic nowadays is blockchain and some of the applications, and I'll talk about it later on. But mainly, actually, this is very important for me to talk about this, because basically in the past, whenever I want to talk about cryptography, people are not interested at all. So basically, they say, oh, what are you talking about? This is mathematics. But nowadays, whenever we talk about blockchain, people will say, yes, blockchain is interesting. But on the other hand, we are not sure whether people really understand what blockchain is. So hopefully in this talk, I'll go through what blockchain is and also what are the applications of blockchain in particular. So those are the ones that I'll be covering. So the content will be like this. So I'll discuss about what's the introduction, what blockchain is, and what are the tools and mechanisms to enable basically blockchain. And then I will go to some of the applications and some of the ongoing research that actually we are doing, and also what are the research direction in this area. So first of all, actually, I think all of us know the word blockchain, but the thing is, in my experience, basically a lot of people actually don't really understand what blockchain is for and what is actually blockchain. So to give you an example, is a lot of industries have been approaching me. They asked to say that, okay, let's try to have a project. So what's the project on? It's on blockchain. But when you ask, what do you want? Doesn't matter, just put blockchain. So that's actually the thing is very clear that they don't have the understanding what blockchain can or cannot do. But the main important thing for them is actually the flavor of the month, which is the keyword blockchain. So actually that's obviously for us, that's not what we want to do. But we really need to understand what blockchain is. Okay, so but interestingly, the concept of blockchain is actually very, very simple, as what I will go through. And in fact, this is what we learned in cryptography from about 30 years ago. So it's not now, it's from 30 years ago. So this is why I go through this introduction. So essentially, when we talk about blockchain, we've never been able to detach ourselves from the issue of having currency. So it's like banking. So this is the view basically when we are doing, like there is whenever we want to open an account, there is a person here, you need to establish an account, and then this is, so basically this is the person who will be, there's a problem with the machine, I think, so sorry. This is Pascal's machine.
No, that's your blockchain.
Alright, sorry. So yeah, but so essentially what I was trying to say is, whenever we want to establish an account, first of all, you need to open an account, and then after that, the bank will assign you the bank card, bank information, and things like that. And then at the end of the day, you are registered to the bank and you can do the transaction. But what happened in that scenario is essentially the bank is the central party in which everyone trusts. So basically, whenever you conduct the transaction, everything actually is done via the bank. So in this case, actually, effectively, you are trusting the bank. Right? So with blockchain, one of the idea is we want actually to remove this trust. So in the case of a financial transaction, for example, we do not want to rely on the bank. So that's what blockchain can offer. So another example is like, I think most of you have heard that recently the Australian government have been creating a new bill. So the bill is basically talking about that basically nowadays when you want to use end-to-end encryption, then essentially the government actually is allowed to, has the right to open your conversation, right? So there is no, on one side you can say that there is no privacy there, but that's not the issue that I want to discuss. But the issue that I want to raise is essentially there is a trust that we need to put, which is to the government. But people from time to time, especially researchers, we always say that we do not want to trust on a single party, including the government, right? So that's actually where blockchain is suitable to enable this non-trusting issue. So essentially, by having some construction that rely on blockchain, what we can achieve is something that you do not really require to trust anyone. So how can we enable this? So essentially, that's the gist of the talk that I will discuss today. How can actually we remove the trust from any central party? Okay, so that's basically the thank you. So should we okay that? Okay, all right. So that's returning to this case. So basically, the bank here is the trust, the trusted party. So we want to remove the central party. So this is just one example. But as what I mentioned earlier, even maybe government is one of the example, another example that we want to remove, right? By using the blockchain infrastructure. So whenever why blockchain actually has gained a lot of momentum, that's actually the first issue is due to the so-called Bitcoin. This is where first blockchain was used. Why Bitcoin actually becomes very important, because the market cap and the price keeps going up. Even recently it drops. But whenever it's associated with money, people becomes interested, right? So when we just talk about mathematics, nobody is interested. But as soon as it talks about money, then people becomes, yes, I want to be a part of it. So that's basically the story. And what's actually Bitcoin? Bitcoin is the so-called cryptocurrency. So essentially, it's a currency, but it's based on cryptography. That's why in the preamble I said that actually I'm very happy that cryptography actually get a lot of attention. People are now get used with the word cryptography. I remember say even 10 years ago when you say cryptography, some people even cannot spell how to pronounce cryptography. So now people know that cryptography is actually very important due to this issue. So Bitcoin is cryptocurrency. This is existing purely for digital realm, so there is not really physical money. It was deployed in 2009. And this is actually a currency that's built upon the computer science, cryptography, and the economics. And then this is born of the cypherpunk movement. So essentially, this is born from people who do not trust any central authority. So in this case, they want to fight for privacy, like self-governance and things like that. And one of the underlying mechanism is due to blockchain. So that's why blockchain is actually the important part here. And obviously, when the first paper was published, this is published by someone who's anonymous. Actually, it used the name Satoshi Nakamoto. Why is that the case? Because as you will see later in the explanation, in the beginning when Bitcoin was first created, the complexity of the problem actually was low. So in that case, people can create the computation easily. So if you can find out the real Satoshi Nakamoto, actually, he must have a lot of Bitcoins. Right, so he must be a millionaire if he cashed all of that. So that's why he has to be anonymous. Otherwise, he may be wrong. Right. So that's the issue. Okay. So what is actually blockchain? Blockchain actually is very simple. It's a chain of blocks. That's why it's called blockchain. It's a public ledger or like a normal database. It records all transactions over P2P network and shared between participants. So essentially, blockchain means just like a normal database. So we all, I think, have studied database. But what's the main difference between blockchain and normal database? In blockchain, basically because the data is available publicly, so nobody actually can modify the contents of the blockchain. So it is unlike the normal database. So it's actually all the data is publicly there, and then what we can do is you can only append the data. So it's only append only. You cannot remove the data. So actually that's the feature of blockchain, which is different, but actually it's interesting. So for example, it's completely different from, for example, if I store the data in the cloud. In cloud computing scenario, I can put my data there and I can remove it. I can actually search through this, but search to the data. But the thing is, the main thing there is I can remove the data, I can change it. But in blockchain, the data cannot be changed. The data, once you write it, it all stays there. Okay, so that's actually the thing. It looks like it's a very simple database in the old days, but this is basically the feature of it. So the feature is basically publicly accessible. Everybody can access this. Why these are all publicly accessible? Essentially, if you want to be informed in blockchain, you should be able to see the contents of this publicly. And there are two roles. You can just see part of the network, or you can act as a person which is known as a miner. So this means basically you will have a role in which to create a new block. So the next one actually is decentralized. There is no centralized party. So it's essentially you don't need to trust anyone. Right? The next one is distributed. It's approved by most peers. So it's because of this issue, then we do not need to really trust on anyone because it's all distributed and cannot be tampered, which is immutable. So these are the components. We have a transaction, obviously, transaction that record a particular transaction, like for example, payment transaction, and then that will compose a list of transactions. We'll create something that's called block. When you join them together, we create something that's called blockchain. So actually, it looks like this. This is the so-called blockchain in practice. Looks like this. So if we study data structure, effectively, this is like in the old day. Data structure is like a normal single linked list, right? So that is like data structure. But here the main difference is basically there is a link to the previous data like this. So this link actually, this one it links to the previous block, and then this is actually the one that is protecting this one because it links to the previous block. Then all the previous block cannot be changed. And how actually we make sure that this cannot be changed is through the mechanism that I will explain next. So basically the structure looks like this, and then all the transactions here are actually recorded via a normal Merkle. This is called Merkle tree hash. So this is like this is hash of this. You comprise. You need to concatenate this one. You get the next hash, so on, and goes to this one. This value will need to be protected for the next transaction. Okay, so that's how it works. It's actually a very simple structure. So this idea actually is really brilliant because all the technique that is being used there are all the old cryptographic technique, but it has been implemented by a lot of software engineers who are very good to do this implementation. Okay, so that's why this Bitcoin in the beginning was very successful. So there are 4 elements that actually characterize blockchain, which is listed here. First one actually is a replicated ledger. So it means that actually the ledger, so the ledger is the list of transactions. They are all available in all the nodes. So if you join the node, you join as a node, basically you will get a copy of all the transactions. So that is why when someone is modifying this record, if you have your own copy, then basically if someone is malicious, you try to modify one record, it doesn't work because the rest of the other people will have the original copy, which doesn't contain the one that you just modified. Does it make sense, the idea? So it's basically suppose that there are 10 of us in the network. One of us is actually malicious, try to modify the contents. But 9 of us says that, no, I don't have that content. And this person says that, no, I have it. So it doesn't matter because actually majority of us are saying that that content doesn't exist. So that's how the security actually is guaranteed, through the majority. Right? So that's the first one, which is the issue that's called replicated ledger. So the one that I just mentioned about this majority, that's something that's called consensus. So this is a decentralized protocol. So essentially there's no central party, but it actually, all of these peers will be able to work together, so and then they will see that what is the majority vote or what is the majority of the contents that everyone agree. Okay, so that's this one to verify the transaction. That's the third component, second component. The third component actually is cryptography to ensure the integrity of the ledger, integrity of the transaction. How it is ensured is by using only two mechanisms, which is a hash function and digital signature that I'll go through next. So that is to make sure that there is authenticity of the transaction. You can have privacy of the transaction and the identity of the participant. So when we want to send money across, for example, the identity needs to be preserved. And the fourth component, which is very important in blockchain, is the business logic. So essentially, this is saying that there should be some business logic that's embedded in the ledger. So we need to be able to have a business case that is embedded in the system. So if we just read some papers actually try to move everything to blockchain. Actually, it does not really make sense if it does not have a business aspect. So the success of Bitcoin actually is due to the fourth component, because it has some money component which influence a lot of people. So that it has business aspect to that. That's why you see a lot of papers, and once we have one new topic, people are writing so many papers, right? But all of those papers, you can see that majority of them are useless because they do not cater for what is the business aspect of moving this into blockchain. So if there is no business aspect, then basically there is no difference between what we are doing now and if you move to the blockchain, right? So that's actually one of the important part in this area of blockchain. So this is an example of where blockchain is used in terms of payment. So suppose that A want to send money to B, and the transaction will be represented online as a block, like one of the block. And then after that, the block will be broadcasted to everyone in the network, and everyone will need to check whether this block is actually okay or not. And then majority of them needs to approve that yes, this transaction is fine. If the transaction is fine, they will add it to their own local copy. So it means that if majority of them actually add in their local copy, that means majority of them accept that this is a valid transaction, right? In that case, the transaction becomes valid. Okay, so that's basically the main idea. And once it is actually recorded locally, if majority number has been met, then the money will move from A to B. Okay, so it's actually very simple, the logic. So this is how it looks like for each transaction. So every transaction actually has the owner, so that's the so-called public key or the owner. So we have so maybe this picture is easier to understand. So this is a transaction that is based on the owner, and from the previous block, we put a hash function to this, and then we need to sign this one. This will become a valid block. And then later on for them, if we want to add the next transaction, you need to see the previous transaction, which is this one, and then you add the new owner, and you hash this, you sign this block, and that becomes a new transaction. So that's how it is linked all together to create a very long block at the end of the day. Okay, so that's why we need to have two cryptographic primitive here, which is hash and a signature. That's needed. So far, actually, blockchain protocol actually has been designed something like this. The original one is called Bitcoin. So it looks like this. It's basically very simple. You can just transfer money and here and there. Very simple script. And then there is a next generation. It's called Monero. It's basically try to anonymize this. So that's why I put like that. It's anonymized, so you hide the value. That's the second, like the next iteration after this. And then the second generation of blockchain is what we call blockchain 2. Is actually more advanced. More advanced because actually if it is in the smartphone, it looks like this, okay? So basically it has something that is known as a smart contract. So basically you can run a contract. So the contract actually is put inside the blockchain, and then whenever there is an event happen, the contract will be automatically run. So to illustrate to you what is a smart contract actually, some people think when I first heard the word smart contract, my imagination was it's like a contract, but it's very clever. But actually smart contract is not very clever. So smart contract is basically a contract which is actually available publicly. You can see it publicly, but the input you need to provide the input. And then this smart contract will generate the output. So to show you with the illustration, it's like you go to a vending machine. So if you go to a vending machine, you actually see everything that you want to see there. It's like there is a bottle of Coke and so on, a bottle of water, there is a can of Coke and so on. So now what you need to do is you insert an input, which is like coin, for example, and then that vending machine will output you something. That's a smart contract. So what is the purpose of having smart contract? Smart contract actually is very useful. For example, the use of smart contract is, for example, in ING, in the insurance company, what they do is, nowadays, suppose that when you go overseas, you take plane, so there is like, for example, if you are late for 4 hours, you will get money back, right? You get some sort of compensation. So this is in the past was organized manually, but now with blockchain, actually, you can do this automatically. How can we do this automatically? I will write a smart contract. So the smart contract basically says, smart contract is actually written in a very simple language like a Python-like. So essentially this will say, I will check, this is your flight number, I will check what time your flight depart, because that one is from the external database, right? And then when your flight actually depart, there is an external event that goes to the smart contract will be executed, and then you will now compare with what time your flight is supposed to depart compared to what time your flight really depart. So in that case, you know the difference. If your difference actually is more than one particular value, then the money will be deposited to your account. If not, then basically the money is deposited to the system. So that's how it works. So in that case, we do not need any interference from people anymore. Okay, so in this case, then by just putting this like a script, a little script, actually the script can run itself. And based on the external event, it can actually do it. So that's actually the so-called smart contract. That's what I view as like a normal smartphone, right? So that's actually blockchain too. People nowadays, so the first one is the blockchain 1.0 is basically in literature people call it as a distributed ledger. That's just distributed ledger. You have a ledger but distributed. That's the first one. Second one is basically you equip this with smart contract, with an ability to run this. Nowadays people are moving towards what will be next for the next blockchain. So this is still in the research space at the moment. Alright, so I will go through briefly about some of the tools that will be used and mechanism. The first one is actually the so-called hash function. So what is a hash function? Hash function is basically a function that accepts any size of data and it will produce a fixed size of output. That's the definition of hash. So it doesn't matter how big your data is. When you give a hash to function to this data, it will give you a fixed amount of output. So for example, this like for example this data, if I give to a hash function like SHA-256 for example, give me like this. But the nice thing about hash function is if you change a little bit of this input, the output is completely different. So that's actually the property of hash function. Okay, so one of the things that is important in hash function is basically it has the property that's called collision free. So essentially it means that if I have two values, x and y, they are not the same, and then in order to find the same hash, this is actually computationally invisible. Why it is computationally invisible? Actually, it's not impossible, because if I come from a large domain and goes to a short outcome, short result, obviously you should be able to find more than one input that will hash to the same output. If you want to have every one-to-one mapping, essentially it means that the size of the input must be equal to the size of the output. Right? So actually in discrete mathematics, in computer science, this is known partly, this can be explained with something that's known as a pigeonhole principle. So basically if you have pigeonhole, you have letters, right? So for example, I have 10 pigeonhole, and then now I have 11 letters. Then definitely one of the pigeonhole will have more than one letter. Because when I distribute one by one, definitely one of them will have more than one. But the question here is to find such a collision actually is very difficult. That's why technically this is called computationally invisible. But it's not impossible. It's always possible. Okay, so that's collision free. So collision to exist because the number input is larger than the output, right? So that actually makes sense. The question is how easy someone to find them. The second property is a property that is called hiding. So this is actually defined like this. If we have a random, we have R is chosen from probability distribution that has high mean entropy. So what is high mean entropy? High mean entropy, it means that the distribution is very spread out. So basically, this distribution is spread out with the same probability. Okay, so and then if we have like this, then if I give you hash of R concatenated with X, then actually it is invisible to find X if R has a high mean entropy. So basically, R to find this X actually is also invisible. So this the third feature is the so-called puzzle friendly. So it means that for every possible output value Y, so that Y is actually the value of the hash. If we choose K from a distribution with high mean entropy, then it is actually invisible to find X such that this hash K concatenated with X will be equal to Y. So essentially this is actually driven from the property, original property of the hash. Okay, so if I give you, basically if I give you one of these, K, to find this X actually is still hard. Okay, so why we need to go to all of this? Essentially, this is related to this, that if I give you a puzzle ID, like ID, which is beside a mean entropy distribution, and a target set Y, and then we want to find a solution X such that the hash of ID concatenated with X is equal to the one that's given. Basically, to find this X is as hard as you just find a random value of this X. You need to try one by one. Okay, there's no other way, no better way than we just try one by one. So if we have this definition, essentially this is also related to this. So when we have a hash function, I mentioned earlier, hash function essentially when you take any size of the message, it will produce a fixed size of the output. So it means, for example, like this, how can we actually achieve like this? This is a simple construction that is known as a Markov-Demkart construction. So basically there is a function called compression function. If this is a message block 1 and this IV is initialization factor, if I give to this compression function, it will give me this output. And if I take the following message, it will give me the same output. And at the end, it will give me 256 bits. So that's actually the way we construct hash function. So you treat this message block separately, but every time it is cascading, and you find the last output. Okay, so that's how we compute the hash in practice. And we have the following this is a big theorem in the literature. If C, this compression function is collision free, then the overall result is actually collision free. Okay, so we actually have a very nice result in this area actually produced by our group that states that prove this construction as well. Right, so this is actually related to why I need to explain all of this. This is related to when it is used in blockchain. When it's used in blockchain and in particular in Bitcoin. So essentially what happened is, as what I showed you earlier, everyone, actually the so-called miner, will need to create a block. So the block is actually a hash of the previous transaction. So the block, that new block, needs to satisfy some property. So this property is the one that I will explain next. So essentially when we want to find a hash, so for example like this one, suppose that if I want to just find any hash, you can see that this is very quick to find out any hash with any no nonce. So basically there is no random in the beginning, no X, right? So sorry, no R, so R concatenated with X. There is no nonce. Actually it's very quick to find a hash. But now if I say that let's try to find a hash function in which the value has 0 in the beginning. So this one will take some time. You can see that it takes some time. Now if I increase, I want to find a hash so that the output will have 2 zeros. This one actually takes longer than this. Now if I want to find the one that has 3 zeros, you can see that the value, this one, it's longer. And now you can imagine that if I need to find a hash so that this one has trailing 20 zeros, that will take some time to generate, right? So essentially, when we want to create a new block, the requirement is due to the number of leading zero that is given here. So the more zero that is being requested, actually that puzzle is harder because it takes more time. Right? So when someone actually can find this one correctly, then that person actually can create a successful block. And then actually in practice, once you create a new block as a miner, so what is a miner? Basically what you do is, any one of you can be a miner. If you want to make money here, of course, one way is to work with Pascal, that's one way. But second way is second way is you can just download an open source from GitHub and then run it, just run it, and then give what is the problem at that time. So for example, at the moment is Bitcoin is like 20 leading zeros. So if you can find 20 leading zeros, that means you have successfully created one block, then you can deposit to the system. Then in that case, you can actually collect the so-called BTC, which is Bitcoin result from that. Right? So that's one way to change when people generate money, is to create correct block. Right? So that's basically the idea from the hash. So it's, at the moment it's about 20 hash per block. So some people actually want to do this, to compete to do this. Due to the difficulty of competing this one, then actually these miners who successfully do this will get their rewards. Okay, so that's actually related to later on that I will explain about the reward. So this is a parameterized cost. So basically everything you can customize depending on the size of the problem. The size problem is higher, that means it's harder. So at the moment the goal is we want to achieve like average time between blocks about 10 minutes. That is in Bitcoin. We create this one every 10 minutes, create one block. Okay, so eventually it will be saturated, right? So when it is saturated, then we increase the complexity. Okay. So there is a key security assumption that the attacks actually invisible if the majority of miners are weighted by the hash follow the protocol. So essentially, it means that if you are one of the miners, basically you download from GitHub, you are becoming one of the miners. It's always assumed that majority of the people are actually following the protocol. Because why we need to have this? Because if majority of people are actually malicious, then there is no security. Okay, so the security of the system actually is assumed due to since everyone can download it and you become miner. So in that case, it's actually next to impossible if you ask everyone to collude to be malicious people, right? Because this is spread all over the world, right? That's actually the assumption, which is quite a reasonable assumption, right? So that nonce also has to be published as part of the block, because nonce actually that's the random design of X. That's actually part of the difficulty of the problem. Then the other miner can just check. For example, if the hash of the nonce concatenated by the previous hash of the block plus all the transaction is actually less than whatever target that's given, like maybe trading 30, for example. Right, so this is how it is done in practice. So for example, in the first block, there is no, because this is first block, that's why I put winner is nobody there. There is no parent, there's no nonce. When you take this one, you will take the hash, this is the first block. The first block is actually related by, for example, player 23. His parent, actually, that's the parent node, and we use these nodes. And the next one, actually, is also you take this hash. This is actually won by this player, and then this has this, the parent is this one, and this is the node, and so on. Why this structure actually very important? Because at some stage, actually, some people, some miners may be creating something that's called forking. So in that case, suppose that I try to collude with several other people, and then I do not follow the path that is actually been happening. So what I do is I just create with all my colleagues to create the longest path. Because one thing that I forgot to mention is the consensus that is done by everyone is based on the longest path. So whoever has the longest path, that is declared to be the real transactions. So in this case, if I create this transaction with all my colleagues, then I can get some of the blocks. If less than 51% people are actually colluding, at the end of the day, some other people will be able to beat my computation and they will get a longer path. So from then on, all of the things that actually I've done with my colleague will actually be discarded. Right? So that's why actually in blockchain, there are so many effort that people have created, have put towards computation, and they are actually not used. Because when you are doing computation, maybe when you are doing computation, some other people in Germany, they are also doing computation, and they find the result before you. So in that case, your result will be removed, right? So that's actually the problem, one of the problem when we create this mining issue. Okay, so this is basically a simple algorithm how to create the hash, to create a new block. So you verify that the hash from the previous block is correct, and then we build a new block with the random norms. And then we need to check, we hash a new block, does it have the n leading zeros, so for example 20 zeros? If not, then you try to build another one with the random norms. You keep doing this until you satisfy this, how many leading zeros that you have. If you satisfy this, then you send the block to everyone. Okay, so it's actually a very simple loop, right? So if we are doing programming, this is actually nothing. It's like first year computer science students should be able to do this. And so the result of step 1, if you can find out how many points anyone has been counting, how many blocks they have won, so basically that's one of the key things that we want. The second part is actually signature scheme. So signature scheme has been long available, but people really just say that, okay, this one theoretical is good. Some people actually use for digital signature, right? So signature algorithm, in fact, is very important to maintain the authenticity of the block. So what is the signature algorithm? Basically, the signature algorithm has two parts. One is the private key, another one is public key. If I want to sign, I will use my private key. If people want to verify, they use my public key. What's the difference between signature scheme and the normal signing? So suppose that if I have a piece of paper, I can sign, and I can show to anyone that yes, indeed the paper has been signed. But you can imagine in digital world, we cannot use the signature and you can just scan it. Because what happens is people will use Photoshop, copy the signature and attach it somewhere. So that's why digital signature is a function, mathematical function, that rely on the contents of the message plus the private key to generate the so-called signature. And then in order to verify, you take the signature and the public key of the person to verify. Okay, so that's basically the digital signature. So what do we want from signature? Basically what we want is, once you sign it, everyone can verify. The signature is tied to a particular document, so we cannot like cut and paste, as what I mentioned earlier, so to another document. So this is how digital signature look like. There is this is PKI setting, public key setting. There is private key and public key. And then when you sign, you use private key. And then when you verify, you use public key, the message, and the signature to see it's valid or not. Right? So this actually we can use this in terms of when we want to use in practice. You can check whether the valid signature can verify. So basically, you can verify a message that has been signed correctly, and the verification is always true. We cannot force the signature. So basically, any adversary who knows the public key will not be able to generate any signature of his choice if he doesn't know the private key, unless the adversary knows the private key. That means the adversary becomes you. Okay, it's the same as signature, normal signature. Anyone is expected not to be able to copy your signature unless it's you, right? So it's the same thing. So we cannot produce a verifiable signature on another message. Right, so in Bitcoin, for example, it uses something that's called ECDSA. It's elliptic curve digital signature algorithm. It has some high-level mathematics. So if you're, maybe if I put it here, everyone will sleep. So I think this one you can look at that if you are interested. Right. So the next one that's important is actually the mechanism that's called incentive. So why everyone want to do this? It's the same as this is the same question as why everyone want to work, because of you get payment. Same here. So why everyone want to go into this is because of block reward. So basically, when you create a block, you get a special coin creation for that block. So if you can successfully create one block, attach it to the network, you get a value which is at the moment is 12.5 BTC. It will halve every 4 years. It's like the normal money. $100 now, and next 4 years it will drop the value, right? It's the same concept. And then the next one is there is something that's called transaction fee. So basically for every single transaction, so if I create a transaction, I put in a block, there is a cost for people actually to put in there, right? So that's actually the so-called transaction fee. This is a transaction fee. Basically, there is no standard setup. It's like a tip, basically, how much the system wants to do. So what about the rules? The law in Bitcoin I mentioned earlier. Whatever 51% of the miners are running will win. So if you have 51% of people colluding, that means the system is not secure. So we assume there will be less than 51% people colluding. So in that case, if we study the theory of distributed system, with 51%, in fact, you can achieve the so-called Byzantine attack, right? So it will resist against Byzantine attack, and it also resists against the so-called cyber attack. Cyber attack is basically an attack in which I pretend to be multiple copy of me. So it's basically I'm one, and then I will be somewhere else. It's me, like my clone, somewhere else. If there are a lot of things like this is called cyber attack. So it has to be resistance against that. So the main issue is if there is some change in the rule, then the system will be broken. So for example, what about if the cryptography breaks? So for example, ECDSA. What about if ECDSA breaks? You may be wondering why ECDSA breaks. Because ECDSA, it may break if, so ECDSA is actually based on some of the problem which is like standard problem, like the so-called discrete logarithm problem. So discrete logarithm problem is known to be not secure when quantum computer is available, because this is due to the Shor's algorithm. So Shor algorithm can actually be used to solve discrete log and factorization in Fermi-nominal time. Okay, so that means that one day when quantum computer is available, then ECDSA is no longer secure. So in that case, you need to replace the ECDSA with an algorithm, new algorithm, which will remain secure even though quantum computer is available. Right? Makes sense, right? So that's the way to do. But replacing actually is not as easy as it says, because when you want to replace, basically the size will change. Everything will change. Basically everything in the network, the environment will change. So that's actually the main problem that we have. What about if you want to add more coins? So essentially, for example, Bitcoin, there is a limitation. At some stage, that stop. You cannot mine anymore. This is the same as the money circulation. At some stage, the reserve bank will say no more circulation of money for a while. Right? So what happens if you want to add money because of some issue? Right? So it's not possible. So that's something we need to resolve. And I mentioned earlier if we want to change the block format. So the attacks I mentioned earlier, which is 51% of the attack. So how can we deter this? I think I mentioned about this cyber attack and so on. So I will touch into some of the application and the ongoing research that is in this area. So these are actually what people have done. I'm not saying that I agree with all of them, but one of the things that is actually very useful for blockchain is we have seen is fintech industry. So financial is actually very useful. There are some other application which is not really convincing because of the fourth part is not there. But anyway, so this is an example of cryptocurrency. There are so many of them. The top two at the moment is Bitcoin, that's the first one, and Ethereum. Ethereum actually is the first one that includes smart contract. Okay, so that's an example. So this is another example that people try to create privacy enhancing. So basically, people try to create when we want to make sure that the person who spend the money, the identity is protected, for example, how to achieve it. So that people have been working in this area, like Dash, Coin, Dash, and the recent one is Monero. So Monero actually is using things like link over link signature, for example. That's the primitive that is being used. Okay, so this is one of the examples when cryptocurrency is used in a bad way. So when this outbreak actually is there, when people want to be paid open. So basically, in this WannaCry, basically your file will be locked, and then you need to pay with some cryptocurrency, and then you will get a decryption key to open your file back. So why this technique actually works? Because in cryptocurrency, your identity actually is preserved. So when you pay to someone, you don't know to whom you pay this to. So in that case, everything works fine, right? So then the party will get the money, you get the decryption key, you really don't know who has hacked into your machine. So that's an example when it's used not really in a good way. This is some work that actually we are trying to do, is to balance between anonymity and accountability. So it's basically, in cryptocurrency, the good thing is actually anonymity. We can provide anonymity, but sometimes you want accountability. People should not do money laundering, for example. So how can actually we achieve this? That's one of the things that we are trying to do. That's actually some of the example of the things that happen in the world. So how can actually we do tracing? At the moment there are 3 different methods. It's based on the transaction analysis, based on what has been done on the previous transaction. It's also based on central party, so that's actually not very good because we want decentralized, right? And the third one is based on cryptography algorithm. That's actually has been using this method like accountable DAP, and also our work that we are doing now on this. So this is basically the layout of our work. Is actually making the so-called traceable Monero. When we spend Monero, and at the end of the day, you can trace back where it is coming from. So maybe I will not go into the detail how it is done. There is another example where it's used to do voting. So this is voting protocol. So when we do voting, people vote, and there is a person who will collect the information and then declare who is the winner. Right? But what we can do is, if we have blockchain, we don't need to have this guy. You put everything in blockchain, and then everyone will know the result at the same time. So that's actually the beauty of that. So no central party, there is automatically compute the final result. That's the so-called self-tolling e-voting. But there is an issue that's called fairness issue. So to show you, to just give you an idea, it's like this. Suppose that there are 5 of us who want to do voting. And then what I can do is, the first person vote, second person vote, and up to the 4th person vote. You can see the 5th person, which is the last one. Actually, before he put his vote, he can see what the others have voted, because they are all in blockchain. So in that case, he will know that, for example, if everybody has voted for one candidate, if he votes for another candidate, actually it doesn't matter, then he will lose anyway. You get what I mean? So in that case, it's better for him, for the last person, not to vote. Because if he doesn't vote, and we require 5 people, then the protocol will not work. Then they say the vote is cancelled. Right? So we want to, there is a problem there, we want to stop against this problem. Okay, so I think that's actually the inherent issue of this, but we can actually try to resolve this problem. So it's basically, this is the idea. All the voters will need to put everything in the blockchain. This is the starting point, which is usually called Genesis. Right? So and then everyone will put the vote there, and then at the end of the day, when the last person actually put there, everyone will get the result at the same time, simultaneously. Okay, so that's one of the example. Another example is post-quantum blockchain. This is another direction. So I mentioned to you earlier, when quantum computer is available, then basically everything that we have now actually is broken. Right? So you have, for example, SSL, SSH, they are all based on RSA. Right? So factorization, they are all broken. So we actually want to make it post-quantum resistant, meaning that after quantum computer is available, how to make it still resistant. So at the moment, actually, NIST, US National Institute of Standard Technology, is calling for standardization in post-quantum. And in fact, our group has submitted 2 algorithms as part of this standardization. Actually, we are the only university that actually submitted 2 algorithms from New South Wales. There is another one is from Monash University. Actually, there are 4. The other one is from Data 61, but Data 61 proposal was actually shown to be not secure in the first stage. They put it in, but not secure. And so that's one of the direction. So people may be wondering, what about artificial intelligence? Every day now we talk about artificial intelligence. Even my son talk about artificial intelligence. I have a 4-year son. If I ask him, in the old days, if I ask people, What is ABC? People say that this is apple, banana, carrot. But nowadays, if I ask my son, he say artificial intelligence, blockchain, and cybersecurity. So this is completely different now, right? So what about artificial intelligence? Basically, this is artificial intelligence. You can imagine that if we put artificial intelligence using blockchain at the top of blockchain, maybe this Pascal will be interested to put in the living lab, right? So yes. To do this artificial, we have to be very careful because this one is actually very nice idea. But if this got hacked, this artificial intelligence got hacked, that means everyone in this node here actually will be hacked, right? That means if you kill one of these, it will become alive again. Why? Because the copy is everywhere. Do you understand the idea? The copy is everywhere. So that means if you kill one here, it doesn't matter. Because everywhere else is still available. So you can imagine that in the worst scenarios, this is like a robot. You kill one robot, it comes alive again. So you cannot remove this if this is in the blockchain. In fact, Hollywood movie is very good to talk about cryptography usually, and they have done this one as well. How to remove when this happens. In fact, I think most of you have watched this. If this happens, how can actually we handle this? The only way to handle this is by calling everything. Yeah, this is called the Age of Ultron. If you see the Age of Ultron, that's basically what it is. Yeah, so like you see in this movie, you kill the robot, it comes back to life. Why it is like that? Because it is in the blockchain. Right? The blockchain, so it is copied everywhere. Right? So that's why it's all there. Right? So what about blockchain in practice? People actually have really used blockchain in practice. So this is an example to do forecasting. So like this is an example in which people try to make this one as a useful product, but not very successful in my view because it doesn't touch the fourth component. This is another example that Philips actually are doing healthcare. This is Philips blockchain. They are doing healthcare with this. This actually is quite promising, but still in the research space. This is actually done by one of our colleagues in Hong Kong. They are actually doing property management. So essentially the idea is when people buy property, it's all put in the blockchain. So you don't need to go to your solicitor and everything is in there, transparent. Then the bank will know straight away at the time. So that's actually done directly. The next question is what will be the next killer application? We know that fintech is actually killer application, but so far there is no killer application yet. All of these are applications, but they are not killer application. Okay, so that's we need to answer this question. If anyone, so this is actually $1 million question. So how can actually we find this? The last one that I want to show you is basically this is a myth versus reality. Maybe you may notice this. So this is basically what happened. Before, actually what we do is we transfer our money with PayPal, with Visa to another bank, to another person, right? That's what happened. With all of this blockchain technology, what we want is you transfer to another person without bank. Yes, that's what we want. Because you remove the third party, is what happened. But in practice, basically, this is not what happened. In practice, it's like this. You send to the bank go to PayPal, bank go to Bitcoin go, right? So this is what happened. So you can see that sometimes this myth is not really representing what is in reality. And so I thought that that's actually important. The very last question that I want to raise our attention is actually, is the decentralized the main thing, or we want to return to centralized? Right? So this is always the question. If you look at the design of EOS is a new blockchain, which is just about 6 months ago. They released, but it's actually a lot of people use this EOS. This is not Canon EOS actually, right? So EOS is blockchain. So basically this EOS has 21 nodes only, so 21 nodes that can mine. But the 21 nodes actually are given to big companies. So for example, like banks, big banks and this, right? So if you think about it, are they really miners? Because miners you should be able to get from GitHub and you become miner. But they just give to 21 miners. So if you think about it, is that really decentralized? So that's the question. Right, so now the main question is, do we really need fully decentralized, or we need a little bit decentralized, like off-chain, for example. So that's actually the question that researchers want to solve. But maybe that's about it. With that, I'll conclude the talk. Thank you.
Questions, comments? One.
How far do you think we are from getting rid of real estate agencies? Like, it's a nightmare we all face as people that rent property or buy property.
Yes.
And
Yes.
I've thought about whether one day we could, buyers and sellers could come together without this.
Well, actually, in Australia, I know that this has been trial. So actually, one thing that I didn't mention is in blockchain, there are basically 3 types of different blockchain. One is public blockchain, everyone can see. The other one is actually private blockchain, so it's only, for example, used by banks, right? So, and then the third one is hybrid model. So actually, in Australia, we've been trialing several companies. We've been trialing to replace this, like what our colleague in Hong Kong are doing. Is by to replace, for example, when you want to rent a place, when you want to buy like housing and pricing and so on. So currently the real estate agent, they are embarking into this. So eventually not in the long time, so I think we will all be looking into this. From customer point of view, maybe we don't see too much, but the back end is done by using blockchain. So yeah, to answer the question is, I think we are not long to that time, because it's basically it can be achieved with private blockchain easily. If it's public blockchain, it's hard, because public blockchain meaning that everyone can contribute, right? This is not what we want. It's just for example, to replace real estate, and that's easier.
Yeah, really. The other day I was listening about the various applications of blockchain, and then one of them was data privacy.
Yes.
So then you will be owner of your data. Nobody can put the hand in it.
Yeah.
Right? And then this person was talking about the ones who own data today, like Google, Facebook, right, and Amazon, and they live out of this data. Mm-hmm. So then how close are we to have this privacy, data protection using blockchain? And if so, what is the resistance that those big guys in the data world, right, we're actually placing against them?
Yes, well, I think this is a very interesting question, but this is actually nowadays is becoming important, especially when we talk about the EU, because they have GDPR. So with GDPR, essentially you have, when you have the data, essentially you are the owner of the data, and this big company cannot touch anything. Everything has to have your consent. And actually one of the implications is nowadays it's very easy to report if there is any data breach, right? There is a new Australian legislation was just released as well that talk about, and whenever there is a breach, you can just report it easily. So to answer to the question is, it's not how close. Actually, the technology is there. It's just a matter of if someone can put together a real system in which the system can actually always prompt the user to get their consent prior to their data to be used, then the system will be used. But the question now is, there are several issues along this line. So for example, if you want to have this kind of system, so that means that every time whenever your data will be accessed, you have to be in front of your computer to say yes, 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 like that, right? So do you want to embark in this scenario? Maybe no. That's why we want to have a new system. This is actually, in fact, what I've been asking. What are the next killer application? Maybe the next killer application would be like maybe we use AI or we use new technology in which it can act on your behalf somehow. Whenever there is no big risk, right? When there is no big risk to your data exposure, then this one can actually answer on your behalf. Because otherwise, then actually your convenience will be violated due to the issue of protecting your data, one, to comply with the law, and also to own your own data. Does it answer your question?
Thank you very much.
So going along those lines, what with the EU and the right to be forgotten,
Yes.
how does that, obviously because that you need to reconcile that with the whole blockchain is immutable, you can't really reconcile. So how do you kind of reconcile that?
So basically, like the easiest approach to do that is like this. Whenever I put my data, it has to be encrypted with my key, but I'm the one who put the key. So in that case, if I say that I want my data because rights to be forgotten is actually says that if I don't want my data to be accessed anymore, then basically I will tell people that don't access my data. So in that case, it's the same as I just throw away my key, or I don't want these people to access this, then it's okay. So in that case, essentially it means that you never leak your data directly to the like Facebook or to anyone, but you only give the encrypted version of your data. But somehow this data should be still has some functionality that's needed. For example, like searchability, or you can do like manipulation of the data and things like that, but without exposing the data.
That situation is very dangerous because you may be suffer from dementia. So your key nobody knows, but actually your information is needed by somebody. So how that could be solved?
That's totally different, because what you are referring is that's not the part of EU. This is the pre-class protocol. So basically what happens is, for example, like you have a health record, and then now suddenly you get sick, and then now basically the doctor need to access to that one. That's totally different from what we just discussed. So this is essentially whenever there is like some essential data that is important, we can put this kind of like pre-class protocol to cover that. But to answer to the previous question, discussion is not about this one. So it's not about the sensitive data. It's more towards access, like access control of your data.
But initially is access control. If you also hold all the access control to yourself, the situation might happen incidentally because you actually need other people to access your data, but because you are unconscious.
Yeah, no, that's correct. That's what I was referring to. This is like the so-called pre-class protocol. Is basically meaning that I can open my data plus, but I can actually nominate a group of people. So for example, like doctors or nurse or whoever, then actually they can somehow access this on my behalf if such and such thing happens. So in fact, with blockchain, this is very easy, because actually I can create some easy smart contract to say that, for example, if I'm unconscious, then actually this can be done. So what are the criteria of unconscious? So you can ask several questions, then basically you don't get the answer. So those are the kind of things that we can do. Yes.
Comment to the question. At the AMISIS conference in New Orleans, there was actually blockchain workshop demonstration of the public blockchain demonstration of healthcare, and depending on the way smart contract is written, the P2P sharing of the file, you can specify, I can share certain amount of my health information, like the case was breast cancer. I can share everything with my peers within the group. But I would not certainly health insurance type information is only to the insurance company.
Right,
so
right.
we can write that kind of smart contract.
Yes, yes. Yeah, so this is correct. Yes, this is correct. Yes.
I have one question. You mentioned that the Bitcoin rule can be changed.
Yes. No, it can. It's not. It can be changed. If you need to change it one day, that means you need to change the overall infrastructure.
Okay, so that is done in the consensus algorithm part or business logic thing?
It has to be done in the whole algorithm, not just in the consensus, the whole algorithm.
Okay.
Because you will need to, when you do the block creation, has to be changed. Right? So for example, if you replace the ECDSA with post-quantum version of signature, that means the size, which is now probably 160 bit, and then now you need to change it with 2000 bit. So it's totally different. Yeah, so it's not backward compatible, basically.
I have one question about the sustainability of blockchain, because with blockchain the security is in numbers, and the more you have the nodes, the more computer power you need, so you also have a cost. And the whole revolution of the smart city is not only to add technology and to add security, but also to think about the cost that this technology will have. So what's your feedback on it?
So sorry, I didn't get the question.
Using blockchain
Yes.
is adding a lot of computational power in the process, so it has a cost. for example, in terms of energy.
Oh, yes.
You will have a loss in terms of energy, you have a gain in terms of security, so where do you find the balance? And
this is correct. So everything, because for example, the main issue is like, if it is public blockchain, the more difficulty you put, actually the more loss you will do, right? Because this is proof of work, you do that. So there has been several work that is done in this area. For example, especially if it is consortium blockchain, is private blockchain, you can actually modify the way the consensus algorithm works. So this is to make the problem easier. So in that case, also for example, there is the algorithm that says that we don't want everyone to mine, but actually it's just a few people have been nominated to do the mining. So in that case, you can reduce the cost of this like electricity computation significantly, because this is in the private blockchain. So for example, if we say in the Hyperledger fabric, for example, so this is like a private blockchain, so you can actually control this. But public blockchain, no, we cannot do that, unfortunately. Because public blockchain is, there are so many bad guys out there, so that's a problem, right? Yeah.
Well, I've got one question, comment. My son lives in London and he's been spending his nights. Who's a miner, by the way? Here? No one? Okay. So he's been mining for 2 years at night.
Yeah.
He doesn't make sense. So he's made money and then lost the money, and so not much. He cannot buy a new house in London yet. But he was telling me that within the last 2 years, first when he started, it took 10 minutes for a transaction. Now sometimes a bad day, it takes up to 40 minutes. So upscaling obviously is an issue. There have been many papers, and we're talking public blockchain. So is this a dead end, basically? The public, at least the speculative point, like, is it a dead end where we're going nowhere with that, or is there somewhere?
I think public blockchain, especially if we want to mine in Australia, is not a good idea. Because here actually there has been a study to say that like how many minutes you spend and also how much is the electricity cost. That's actually far too expensive. So that's why miners are basically in maybe China, in India, that's where electricity is actually cheaper. So in Australia, I think it's not a good idea, well, unless in the lab.
Don't forget me. Please.
Just a question around the use of blockchain in scientific publishing. There's a couple of papers produced where a whole bunch of people got together at a conference at the start of the year, and there's an Australian group called Frankel, which was part of it. I was just wondering if you had an opinion on adoption, particularly here at the University of Wollongong. Is it likely to be something that might be looked at by the academics in terms of adopting blockchain into the publishing side of things? Is anyone here actually using it or interested in using it?
Well, the thing is, to me, I think there are two sides of publishing, because something that when you write the publication in the top tier places, you try to make it looks very complicated, right? It looks very complicated, and maybe you don't have any business case. When people use it in practice, maybe it's not that complicated. So that's actually the main difference. So I think and I've seen actually several papers, not just in blockchain. For example, when first we talk about cloud computing, there are so many papers that are actually wrong. But there are thousands of them, right? It's not hundreds, just thousands of them. They are wrong and cannot be implemented at all.
So I guess I wasn't talking about papers about blockchain, but actually using blockchain as part of the publication process. So for example, the next paper that you write, publish, would you look at one of the blockchain methods as part of the publication mechanism that you would go through, or is it not too likely, you think it's not mature enough, or there's no academic benefit to you in a number of these systems in terms of
So I think when you so basically your question is, do you use blockchain as a tool for publishing?
Yeah. Because there are some tools now.
Tool for publishing, probably no.
Okay.
Yes, not for tools for but when we want to write research paper, we still want to do that. Yes.
Okay.
Another question coming.
Yeah. So when you talk about mining, which is the way of creating new blocks,
yes,
is that right?
Yes.
Is that sort of limited to currency? Like, is that even needed?
No. It's to create a block in the blockchain.
Yeah.
So that's actually one of the issue that majority of people have, because people, when we talk about blockchain, they always think that this is cryptocurrency. But blockchain is not related to cryptocurrency only. So cryptocurrency uses blockchain, but when we talk about blockchain, it has many applications other than cryptocurrency. So when we want to create a mining, basically the idea is you create the block. So what do you want to use the block for? For anything. It depends on the application. That's actually the question that I was asking. What's the application, which is very good.
So if the application is publishing a paper, and
yes.
you have a paper published,
yes.
is that the style of block? You just create your own block?
Yeah, you can create a block.
Mining
Yes.
or anything, you just create a block.
You still have to do the mining, because when you do the mining, essentially make sure that that block is valid. So it will maintain all the integrity of the previous block. But the question that actually I will be asking is like, what is the benefit for people to create this block? Right? Because like for cryptocurrency, the benefit is easy, it's very clear. They create this one, they get payment. And then someone want to put the transaction in there, they get transaction fee. Very clear. But now if it is in academia...
Yeah, but I've heard them using blockchain in tracking food.
Yes.
For instance, strawberries might be useful
Yes.
at the moment
Yes.
to track, the path of
This is mainly private blockchain.
Right, so I see.
Yeah, this is private blockchain, so you are not really interested in to get the financial thing. It's just like, basically you use blockchain like a database to make sure that you can track and nobody can modify. So that is possible as well. Yeah, that's possible, but whether it will be used by everyone in the world, I guess no.
Is it that's an interesting thing, because in this case you've got a physical object, no longer a digital object, like a contract or a currency, a cryptocurrency,
Yes.
that you have to tie with its digital twin.
Yes.
So I don't know whether there's a needle in the bloody strawberry or not. Even if you can, that's interesting. Yeah, so my last question. We've got issues at Smart with blockchain and this ongoing discussion. We can see two applications in kind of work we're doing. One on the microgrid and exchange, so getting the value out of the blockchain itself, but the kind of contract we transfer.
Yes.
So one is electricity produced locally at microgrid level,
Okay.
and there's already a couple of startups in
Yeah,
Australia selling this kind of algorithm. That's one thing. The second thing we're thinking about, and colleagues in Amsterdam have started playing with it, when you think about smart cities and IoT,
Okay.
the value is in the data again.
Yes.
And not really because you want to sell the data because it's yours, it's because if I'm player A with 200 sensors in the city and player B with another 200, and for one of my backend application I need your data, so 200 plus 200, but you need only 50 of mine, there's an asymmetry of requests.
Okay.
And in this case, a blockchain could, on one-on-one, put a value on my data versus your data. And the value of each data will be the same, but there's a transaction. You see what I mean? So these are the two things we're thinking about, whether in terms of scalability, we're talking rubbish or not, we're not sure. But so do you see some, or have you heard about any implementation like that so far?
No, actually.
Okay.
I don't know the first one, yes. With the electricity.
Yeah, because I've met with the director of our Edge recently.
Right.
Last comment, question? No? Well, please join me again for a fantastic talk.